Hi everyone. So in this video also we are going to continue the paging and segmentation, right? So in the previous video I have mentioned about what is page table and what is segment table I have mentioned. So here we will discuss a little bit more about the segment table, right? Okay. So here also you need to understand that in segment table, okay, so if the program is divided into number of segments, right? Okay, the program may have the code part, then functions, then data, then other references will be there. The model will be there, right? Okay, these models may be considered as segments in the logical part, right? Okay, so your CPU will generate the logical address. That logical address need to be mapped with the physical address, right? Okay, then you need to consider while you are converting this logical address to physical address, you need to verify the segment table, right? Okay, segment table have three different components. One is the segment number, and second one is the base address, and third one is the limit address, right? These three are the combinations, right? Components will be there inside the page table, right? Okay, so now here you need to understand that how this logical address will be generated. So logical address have two components. So here one is the segment number and second one is the offset. This is how your logical address will be generated. Example, you just consider that for segment number 0, how the logical address will be generated. So here logical address may have two components, right? Here this is the segment number and your offset may be, example, consider 430. If it is coming like this, right? Then how you can understand that how this logical address, this is the component, this is the view of logical address. So logical address need to be converted into a physical address. Now here, so segment number 0, automatically it will come here segment number 0, right? Okay. So now segment number 0 have again two components, right? Okay, one is the base address, another one is the limit address, right? Okay, so base address is 1200 and limit is 600. Okay, so now you need to get the whole combination. So here now the offset, if the offset comes for this segment number 0, then how it will be? So it maybe starts with this base address is 1200 but limit address is 600. So here the range, right? Okay, the range may start from 0 to 599. So this may be the offset. Within this, if the logical address is coming within this offset range, okay, offset range, that address will not create any error. Now we will check with this one, right? So this one is what? So 430. So 430, right? Okay. So now here 1200 is the base. Automatically this 430 lies between this 0 to 599. Okay, there is no problem with that. So plus 430. So now your physical address range may be 1630. Like this it may be. Physical address now it may be calculated like this. Okay. So now here one more thing. If I am going with another range, another one, if the error comes, if the address error when it comes, so we will go with this one, right? Okay, for the segment number 1. So if I am saying that here segment number 1, so my offset value is 100. Okay, if my logical address is generated, if my logical address is generated like this, okay. So now again you need to understand that in segment number 1, so what are the components available? Segment number 1, here 50 is there and the range is, that is the limit is 100. Okay, so now, so here again the offset range must be 0 to 99. This one be, okay. So how the offset range will be calculated? That is limit minus 1 is the formula for offset, right? Okay, so now this need to be 0 to 99. The offset range will accept only within this range. But what is my offset value here? This one has been generated by my CPU. CPU generated 1 is the segment number and 0 is 1000 is the offset number. Now you just understand that here. So what will come here? So my base value is 50 plus my offset value is 100. Then value is 150. But what actually is required? So this is 99, right? Okay. So 50 plus 99. So offset range must be within 149. So here 150 greater than 149. Surely there will be an error. So address error. Address error will come. Right? This is how you can understand what is segment table how the logical address will be generated, how you can calculate the physical address, right? And same time, how you can identify whether this physical address may create the error or not, right? So we'll continue in the next video also. We'll see what is the page replacement algorithms, right? Okay, thank you.